everyone. Today we're going to look at how we can move from factored form of an equation to standard or expanded form of the equation. We know that a factored form has two sets of brackets in most cases. For example, y equals, and then in brackets x plus 1, multiplied by another set of brackets with x plus 4 is an example of a factored form equation. A standard form equation, for the most part, will have three terms. It'll look something like y equals x squared plus 5x plus 4. We want to look at how we can change the factored form equations into the standard form equations. There are three ways that we can do this, and you're going to choose the method that you like best. Our first method uses algebra tiles. In the tile method, we take what's in the first set of brackets. In our example of y equals x plus 1 multiplied by x plus 4, we will color the x on the left-hand side of our tile diagram and the 1 below it. So we've got a rectangle and a small square to represent x plus 1. Across the top, we'll have x plus 4. So we'll have one rectangle and then 4 of the small square tiles. We'll use this to develop an area model. So we'll look at what would x plus 1 be if it's multiplied by x plus 4. We know that our answer will need to fit in the space of the rectangle that looks like this. And then to find out the answer, or the expanded form, we'll look at what's inside that rectangle that we've created. So we'll see in there that there's an x squared, there's the 4 x's, and then another x for a total of 5x, and then there are 4 little squares. This gives us a total inventory inside that rectangle of x squared plus 5x plus 4. This is our standard form or expanded form of our original factored form expression. The chart method is similar to the tile method, but it does it without using actual tiles. So along the left side, we'll put x and plus 1, and then along the top, we'll have x plus 4. Inside the chart, we will find what happens when you multiply each of the items. So x times x will give us x squared. X times positive 4 will give us positive 4x. 1 times x will give us 1x. And 1 times 4 will give us positive 4. We can put all of these together, and then we can look for where we can collect the like terms. The 4x and the 1x can be combined to give us 5x. So our equation, when it's in standard or expanded form, will be y equals x squared plus 5x plus 4. In the final method, we'll use algebra. So we'll take our original factored form of y equals x plus 1 in the first set of brackets, and then x plus 4 in the second set of brackets, and we'll use the double distributive property to find out our answer. So everything in the first set of brackets will need to multiply with everything in the second set of brackets. Let's start by distributing the x. X times x will give us x squared. X times 4 will give us plus 4x. Now we'll multiply the 1 by everything in the second set of brackets. So 1 times x will give us 1x, and 1 times 4 will give us 4. Once again, we'll look to simplify by collecting like terms. The 4x and the 1x can be combined to be 5x. So our equation in standard or expanded form will be y equals x squared plus 5x plus 4. These are the three methods that you can use to move from factored form into expanded or standard form. You'll get comfortable using a method, and that will be the one you'll most likely use when you answer these types of questions. Let's look at these three methods for three different examples. In our first equation, we have y equals x plus 5, all multiplied by x plus 3. Once again, using the tile method, we will represent what's in the first set of brackets along the left side. So we'll have one rectangle and 5 number tiles. Across the top, we'll have one rectangle and 3 number tiles to represent the x plus 3. We'll draw our rectangle that will contain our answer. We'll take inventory of what's inside that rectangle. We'll have 1x squared, There's 3 x's and then another 5 x's for a total of 8 x's. and then there are 15 number tiles. So our expanded form will be y equals x squared plus 8x plus 15. We can move to the chart method. Along the side, we'll have x plus 5, and across the top, we'll have x plus 3. As we multiply, x times x will give us x squared, x times 3 will give us 3x, 5 times x will give us 5x, and 5 times 3 will give us 15. We'll finish writing our expanded form by adding together the like terms of 5x and 3x for a total of 8x. Our expanded form will then be y equals x squared plus 8x plus 15. Note that it's the same as when we did it with the tile method. Now let's use the algebra method. Y is equal to x plus 5, all multiplied by x plus 3. We'll multiply the x with the second set of brackets first. We'll get x squared plus 3x, and then we'll multiply the 5 by what's in the second set of brackets. This will give us 5x plus 15. Again, we'll collect the like terms so that we have 3x plus 5x will give us 8x. So our expanded form, again, is y equals x squared plus 8x plus 15. So again, you can see that it doesn't matter which of the methods you use, you'll get the same answer. Let's look at the second example, y equals bracket x plus 1, close bracket, squared. Remember that when something is squared, it means it's multiplied by itself. So in this case, we could rewrite this to say y equals x plus 1, also multiplied by x plus 1. On the left side of our tile drawing, we'll have one rectangle and one small tile. We'll also have the same thing across the top. When we draw a rectangle to find out our area, we'll see that we have x squared and 2 x's and then one number tile. With our chart method, we'll have x plus 1 along the side and x plus 1 along the top. X times x will give us x squared. X times plus 1 will give us 1x. 1 times x will give us plus 1x, and 1 times 1 will give us 1. We'll collect the like terms of the 1x and the 1x to get 2x, and our expanded form will be y equals x squared plus 2x plus 1. With the algebra method, we'll multiply the x by everything in the second set of brackets to give us x squared plus 1x, and then we'll multiply the 1 by everything in the second set of brackets to have 1x plus 1. We'll collect the like terms, and we'll wind up with y equals x squared plus 2x plus 1. In our third example, you'll see that some negatives are being introduced. This makes it a little more complicated when we look at our tile method. So, along our left side, we will have a rectangle and 2 blue small squares. Across the top, we'll have a rectangle and 3 small red squares. When we do x times x, we'll get x squared. And then when we multiply x by each of the small positive ones, we will have 1x. So we'll have a total of 3 x's that are red. Then we need to multiply our negative 1 by x. That'll give us a blue or a negative x. We'll multiply each of the negative ones by each of the positive ones, and this will wind up leaving us with negative 6. This means that our total inventory will involve some cancellation of 0 pairs. The 2 negative x's are going to cancel with 2 of the positive x's. This will leave us with y equals x squared plus 1x minus 6. In our chart method, we'll have x minus 2 along the left-hand side, and then we'll have x plus 3 along the top. X times x will give us x squared. X times 3 will give us 3x. Negative 2 times x will give us negative 2x, and negative 2 times positive 3 will give us negative 6. We'll collect our like terms so that negative 2x and positive 3x will give us 1x. Our expanded form will be y equals x squared plus x, or 1x, minus 6. In our algebra method, we'll take the x and multiply it by everything in the second set of brackets. This will leave us with y equals x squared plus 3x, and then we'll multiply the negative 2 by everything in the second set of brackets. This will give us negative 2x minus 6. As we simplify, we'll have y equals x squared plus x minus 6. So of the three methods, the tile, the chart, and the algebra, take a look and see which one seems to make the most sense for you. This will be the method you will use moving forward when you're trying to convert something that's in factored form into expanded form. This is all going to be helpful as you try to graph parabolas and you need to determine the x-intercepts or the y-intercepts before you begin to graph.